Hello everyone, this video is related to visual approach of solving the numericals on the design of dam. So this video is specially designed for the civil engineers who are specializing in hydropower engineering or the design of dam. So let's get started. First, I have got this SketchUp window. First, I will open the dynamic dam which I have designed. I'll import it into the SketchUp file and I'll just keep it over here. The main benefit of using dynamic components in solving this problem is that we can change the parameters and the dimensions will get automatically changed and all the forces can be calculated quite easily. So in this scenario, I will just select this dam, right click and go to the component options, and we will try to solve one numerical over there. So first we have to input the coefficient of friction, which is generally represented as mu. So let's keep as it is. So downstream head, as you can see, this is the downstream part. It has already shown the dimensions of 6 meters. So all the dimensions are in meter here. So we can change the downstream head as 5, and if you press enter, so this dimension will automatically get changed and this water level will also get changed. Let's keep it as 6 meter. Then we'll go to downstream triangle base length. So this dam consists of different parts. So this is the main concrete section of the dam. So in the lower portion there is a triangular part. So we need to input the downstream triangle base length. So as you can see, the downstream triangle base length is 50 meter is given. So we can just change this value as per your need. Let's say 40 meter and press enter. The size will get automatically adjusted. For now, let's keep as it is as 50. The downstream triangle height. So this 75 meter is nothing but the height from here to here. So you can also change the parameters like 60. It will decrease the height. 70 to change the dimension as you go. So location of drainage gallery. So there's also the presence of drainage gallery over here. If there is no drainage gallery, you can just set it no and then press enter. The drainage gallery will be disclosed and automatically the uplift force will also get this triangular in shape. So for now I'm just getting it as drainage gallery yes. So when there is a drainage gallery, the uplift force will get reduced. And then so location of drainage gallery from the main dam left. So the drainage gallery is usually considered from starting from here. So the distance of drainage gallery is 8 meter from left of this side to here. So you can change this distance. So specific weight of concrete we have given 23,500. Specific weight of water is 9810. The height of the dam is 84. So this is the distance from here to here, the overall distance. So you can also change it. And then compressive strength of concrete is given. It is in Newton per meter square. The top width you can change that. So it is by default 6 meter. You can change this width also. And the uplift coefficient is 1. Sometimes you may get uplift coefficient as 0.9. That means that so the height of the uplift pressure will get reduced if we use 0.1. For now, let's assume that the uplift coefficient is just 1. And you can change the upstream height. For example, it's 80 over here. You can change this to 50. So and the uplift force and everything will get automatically adjusted. For now, let's keep it as 80. Another one is upstream triangle base length is given. So sometimes we also need to produce some concrete in this section also. So for that, the upstream triangle base length is given. Let's say it has 15. Then what happens is that it will create one concrete section over here, and in that portion what happens is that some water portion is also added over there. So it will automatically get adjusted as we need to find the weight of water also in this section. So you can also change the upstream triangle height. Let's say it as 30. So in this scenario the height will get changed. So for now I'm just giving it as 0. So there is no any weight of water in the uppermost section. So by changing the parameters, you can just work on with different parameters. And the force diagram, and this is the force diagram of the hydrostatic pressure downstream, and this is the hydrostatic pressure force diagram for the downstream side, and this is the uplift force diagram. So there are 4 diagrams. One is triangle, rectangular, rectangular, and another triangular part over here. Now for the output section, what you can do is that one option is just double click on this section and then right click and go to dynamic components and select component options. So what it gives is that, so it gives the overall hydrostatic horizontal force. So this value is in Newton, so it is acting on that direction, and it gives the lever arm, and it gives the moment about the point here. The same is the case with all other components. For example, if you want to know the value of weight for this strip of concrete, you can just click on this and right click, go to dynamic components and component options. You can see the lever arm is given, the total weight is given in Newton, and the moment is given in Newton meter. So similarly you can do for all other sections as well. So moment, weight, and lever arm, and then you can also go for the uplift part also to find out the total uplift force, the moment, and its lever arm. So if you are trying to do it manually, you can just check out whether your calculations are going easy or not. And at last, for the final output, what you can do is that you can go to these dynamic components. If this is not present, you can go to view, then toolbars, and check on this dynamic components. So this dialog box will appear, and after that what you will do is you'll just click on this interact with dynamic components, and if you just click on this section, it will give the overall output of the 10. So the net vertical force is given, the net horizontal force is given, the net resisting moment is given, net overturning moment, and the factor of safety for overturning. So for sliding it's not okay. The eccentricity is given, shear friction factor given, stress at the toe edge, stress at the heel, principal stress, shear stress, and everything is given over here. You can just play with different parameters and then do as per your requirement. And the eccentricity value is also given, that is 9.93. so the dimension is already been expressed in the figure. So this is the midpoint of the base, and this is the point where the resultant vertical force is acting on. So this will be the required eccentricity, or 9.93 meter in this case. So to get this dynamic component in your model, you can just see in the description and contact me. Thanks for watching.